Hello everyone. So for today's topic, we're gonna learn about the atmospheric dispersion modeling. So my name is ADREENA BINTI SHAHRUL HISHAM. So for the introduction, the atmospheric dispersion modeling is a scientific approach used to stimulate and predict the spread and concentration of air pollutant released into the atmosphere. This modeling technique is employed in air quality management and environmental impact assessment to understand how the pollutant disperse, react, and accumulate in the air. In this modeling include the emission sources. These emission sources is identifying and quantifying the location and rate at which pollutants are released into the atmosphere from various sources such as industrial facilities, traffic, or other human activity. Next is the meteorological condition, which is considering local meteorological factors like wind speed, wind direction, atmospheric stability, and temperature, as this significantly influence the dispersion pattern of pollutant. Next is the topography and geography. This Topography and geography is to recognizing the impact of the local landscape on dispersion pattern as the presence of hills, valley, and other geographical features can influence the movement of pollutant. So next is the physical explanation for the dispersion. The dispersion of pollutant in the atmosphere is a complex process influenced by various factors. So below is some of the factors that contribute when there is a continuous stream or pollutant release into a steady wind. So firstly, the factor that include here is the plumb rise and dispersion in wind, role of eddies in turbulent flow, the formation of eddies, random wind shift times average plumb consideration, binormal distribution in vertical and lateral direction, and Vikian diffusion equation, and lastly is Gaussian dispersion equation. So for the first factor is the plumb rise and dispersion in the wind. The plumb rise is due to the buoyancy and depends over traveling with the mean wind. Next is the mean wind, which is it carries the pollutant away from the source, and the plumb disperses both horizontally and vertically. And next is the roles of eddy in turbulent flow. Turbulent flow is in the atmosphere, which is contain the eddy, and also which are random fluctuation in the flow. And eddies in turbulent flow is intersected by part of the plume and is exchanging concentrated pollutant with clean air, which is leading to plume bordering and dilution. Next is the formation of eddy. In this factor, the thermal eddy results from the absorption of solar energy by the ground, which is create the conduction or the convection-induced fluctuation. And next is mechanical eddies arise from shear force caused by wind across roof surface with greater roundness and stronger winds producing more eddies. Next factor is random wind shifts. Random shift in wind direction contribute to plumb spread over time. And the pollutant concentration are measured over an averaging time, which the wind fluctuating can cause the shift and contributing to plumb dispersion. And the next factor is time average plumb consideration. So due to eddies and wind fluctuation, the plumb must be considered on a time average basis rather than instantaneously. And next is the binormal distribution in vertical and lateral direction. The plumb spread occur in both lateral and vertical direction, and the distribution of pollutant concentration is termed binormal and is influenced by the eddies distribution. And the second last factor is Vikian diffusion equation. A model based on Fickian diffusion equation approximates plum behavior by considering average additivity and a steady wind. So in this equation, it predicts that pollutant concentration needs to be a binomial distributed in both the lateral and vertical direction. And lastly is the Gaussian dispersion equation. Um, in this equation, it is another valid modeling approach, which is considered the statistical nature of dispersion process. So as we can summarize, this dispersion of pollutant involves a combination of physical process including plumb rise, turbulent flow, eddy interaction with point fluctuation, and the statistic modeling. So here is the Gaussian model, which is given the equation of this model. What can be termed a Gaussian or called a normal distribution often result from the random process. So this equation below is the form that predicts the steady state concentration at the point x, y, z, which is located downwind from the source. So in the equation 20.1, here shown the equation that used for the Gaussian model. So as we can see here in the figure 20.4 is the model that had been shown from the equation before. So it's coordinate system showing that the Gaussian distribution in the horizontal and vertical. So as we can see here in the equation 20.2a, it states that without the second exponential terms in z, which is from the equation 20.1, the equation will be in the equation 20.2a. So from this equation 20.2a, it depicted the figure from the figure 20.5a shows that pollutant dispersion infinitely in the z direction, including the underground. So next is for the equation 20.2b is for the image source. So when the equation 20.2a and the equation 20.2b are added, it will result the equation 20.1, and this behavior is depicted in figure 20.5b. So next is the atmospheric stability classes. So as can we explain the concept of atmospheric stability and the importance of diffusion parameter in understanding the vertical mixing of air. It also introduced the Pascal-Gifford system for estimating dispersion parameter, which has been widely adopted. And the stability classes A through F are defined based on atmospheric condition, with A representing the most unstable and F is the most stable. The passage highlights the significance of atmospheric stability in pollutant dispersion. So as we can see here is the stability classes for the atmospheric, and we can see from the stable and to unstable. So here the next is the dependence of concentration on averaging time. For averaging time between 10 minutes and 5 hours, data reported by Hino suggested that the concentration at two averaging time are related in equation 20.5 below. So here below is the equation that related to the averaging time and the concentration, where the T is the averaging time and the CT is the concentration for averaging time. Next is the estimating the downwind concentration under an elevated inversion. An elevated inversion can act as a lead to prevent the upward dispersion of pollutant as shown in figure 20.11. Here is the figures below, which is plumb dispersion under an elevated inversion. So based on this figure, there are equations that model a travel plumb is, which is equation 20.7. So from the equation, fumigation of a plum can occur. Fumigation describes the situation in which an unstable boundary layer grows up to a penny plum and quickly makes it vertically throughout the distance between the ground and the plum. So under this condition, the equation that best predict the downward concentration is equation 20.8. Which is a complete mixing is assumed within the box and the outlet concentration is given in equation 20.10, which is from the equation 20.8. So the given equation 20.8 is the equation that can predict the downwind concentration. So to complete the mixing from the concentration, we can use the equation from 20.10, which is to assume that within the bulk and the outlet concentration given. So for the tall stack, actually there are steps that we can use to view the result of this part, which is firstly we analyze the meteorology and then make a preliminary hazard assessment based on meteorology, and after that we test the various cases of physical stack parameter, which is the height and the diameter, and then plum rise models, plan location in conjunction with the worst case meteorology, and after that, after done with all the tests, we need to consider the effect of the local terrain, and after that, after done with consider the effect, the test, and the hazard, we can review the result of the tall stack. So for the plum rise part, one well-known plum rise equation is the Holland formula, which at one time was recommended for use by the US EPA. The equation is following below, which is the equation 20.12, where the Vs is the stack gas velocity, U is the mean wind speed at stack height, ds is stack inner diameter, Pa is the atmospheric pressure, Ts is stack gas temperature, and lastly Ta, which is the atmospheric temperature. The last term of the Holland formula is directly related to heat emission rate. So based on from the equation 20.12, it could be written as it could be also written as the equation 20.13 other than 20.12, where the QH is the heat emission rate. So next is to find the SF. Either we can use the equation 20.15 or 20.16. The plum rise as a function of a downwind distance, which is x, is also be calculated by using the equation 20.17 or 20.18. Next is the buoyancy flux term, which is Fp. Below is the given by the bridge as the formula of the buoyancy flux term that can be used, which is the equation 20.19. So lastly is for the stable condition. First, a stability parameter S is calculated as the equation 2020 below, where the delta theta over delta Z is the potential temperature gradient, S is the stability parameter. So if the data are not available for the potential temperature, we can use the equation 20.21 below. So for the critical wind speed, assess weather condition. We need to assess the weather condition for pollutant dispersion. Identify potential hazard based on meteorology factor and the stack parameter and plum rise testing, which is we need to test the various stack and plum parameter based on this critical wind speed. So for the other stack design consideration, as air below past a structure, a low pressure region form behind the structure, and it will resulting in recirculating eddy and wake formation. So the disturbance from building and the stack itself can result in plumb downwash, where the pollutant plumb is pushed downward. And the turbulence owing to building can extend nearly twice the building height and downwind 5 to 10 times the building height. So the possibility is to include the wind turning vanes on the outside of the stack to reduce the low pressure region behind the stack. So in the figure here, which is the figure 20.14, it's shown the typical flow disturbance owing to A and B. So next is the computer programming for dispersion modeling. The atmospheric dispersion modeling is aimed to mathematically or statistically represent the dilution and dispersion of pollutant in the open atmosphere. Gaussian-based models are the most widely used for atmospheric dispersion modeling today. Which is the dispersion parameter in Gaussian model are determined empirically over a limited range of conditions. The popularity of Gaussian model is attributed to their simplicity, ease of understanding, and adaptability to computer program. Computer program can generate answer if the data are input correctly, but users should exercise the caution of the program. Mobile sources and line sources model. In this part, it discussed the mobile sources, particularly about the emission of carbon monoxide, nitrogen oxide, and the volatile of organic compound. The light-duty vehicle, including automobile, SUV, vans, pickups, and motorcycle, are highlighted as the major subgroup emitting a significant portion of this pollutant, which the heavy duty vehicle, which is comprising about 10% of all vehicles, and it emits the nitrogen oxide at higher rates than the light duty vehicle, which is contributing substantially to overall emissions. So for the conclusion, atmospheric dispersion modeling play a really crucial role in understanding and managing air quality by predicting the spread and concentration of pollutant in the atmosphere. This modeling approach is essential for assessing the potential impact of industrial sources, traffic emission, and other human activity on air quality. The dispersion of pollutant is influenced by various factors, including meteorological condition, emission rate, and the chemical reaction. So that's all from me about this topic. Hope that you all understand and can accept the explanation really well. Thank you.